Hello everyone, it's still November the 24th, but this is for tomorrow because tomorrow is Thanksgiving, so I'm gonna do tomorrow's daily challenge today, right? So this is the second session of today, so tomorrow I can just take a break. All right, let's see. We have an easy one, maximum subarray. Let's see what is it. That's like what? Is it 53? So I've done it before. All right. Oh, look at this. We've done it many times. Let's see, how many times have we done it? 2 times. January 14th, April 24th. All right. What is it about? Given an integer array, find a contiguous subarray containing at least one number, which has the largest sum, and return its sum. Largest sum is this. Okay. Largest sum, I probably just add them together. If you have figured out an ON solution, try coding another one using divide and conquer, which is more subtle. Maximum sum subarray. So what will be the ON? I mean, it could be. Isn't that Cardane? The largest sum, right? We want to find the largest sum. So, right, we add it, and if it's -3, so the largest is starting from -3 will be, well, no, largest ending, right? Largest ending at a certain position. So largest ending I here is -2. Largest ending at 1 will be 1. Largest ending at -3 will be -2. That will be actually 4, right? So either me by myself or I at the previous one. So that will be 4. This will be 3. That's actually 5. That's 6. That will be 1. That will be 5. So largest ending I here will be 5. Yeah, so that's a Cardane's. I think that's Cardane's. Not Cardane, Cardine. Cardane. Not 100% sure. But that's a ON solution, right? And we should be looking for. Wait, are you telling me that divide and conquer can make it even faster than ON? I don't know. Maybe it'll be faster. All right. So what do we say? We say we have a res, right, and a current, right, for n in nums. Right, for n in nums, what do we say? We say current will equal to max n or n plus current, and res equals max current, max res and current, and then return res. I think that shall be it, if I'm not mistaken. So this one will be 6. This one will be 1. What's the last one? So I'll just add everything together. This one will be 23. Okay. Nums, max subarray nums. So I think that is it. That's the Cardain solution. I didn't check any edge case, so I'm not sure. Oh! So I think that's probably my problem initially as well. So if I import math, yeah, it never says it's always math.inf. So I'm going to start with a negative. So if we have a -1, right? So we should return -1. Yeah. Same problem as last time, I'm pretty sure. Oh, wait. That was slow. I can take a look. I'm pretty sure the solution is the same, but they probably add the new test cases. That's my guess. $209 test cases. 202 test cases. Yeah. Yeah, this is the same one. What was I doing? Max s equals nums this. Pre is negative. Return max. Oh, that's just the max. S is the current, right? S plus this. S equals this. Max S equals this. And smaller equals 0. Pre is. Yeah. Yeah, that's the same idea, but I have 202 test cases before, and it runs at 40. But today, it runs at here. Okay, so this is well, that's a 53, right? This is ON. So this is a card. I think it's Cardain's algo ON, right? And you're telling me that this one, oh wow, 983. 17. Come on. We could do better than that. Yeah, we did this. Try coding another solution using the divide and conquer approach. All right, divide and conquer. So we divide. Wait, when divide conquer won't be O(n) log n? Shouldn't be even slower than O(n). I will divide. Okay, let's say I'll divide here. So we're gonna find a maximum subarray here. So, and we also need a spanning, right? We need a spanning. How do we find the spanning? So anyway, so this one, each one will return the maximum subarray, the sum of the maximum subarray, right? And after we return the maximum subarray, we have this side, and we need to find whether a spanning will be larger than. How do we do that? Well, if it's a spanning, so we take this, right? If we get half in here, so we take the first one, take the second one, right? And then we just go on both sides. Okay, we go on both sides and see if we can get a larger value. That will be O(n) log n. Why do we do divide and conquer? I don't like divide and conquer. What is the divide and conquer? Actually, no idea. Divide and conquer. Yeah, so we divide. Subarray nums. That's just the two. Okay, that's easy. And I think this is to find the spanning. All right, how do we find spanning? I equals n minus 1. I is larger or equal to L. So we, from this, okay, we keep going. I think it's to find the maximum. Oh, I see. I see how this one goes. Oh, it makes sense now. All right, so we want to find the maximum sum of subarrays starting from this. Right, if we split in here, so we're going to start from this position, keep going this, and then look for the maximum sum that we can get. So we just keep going and keep track of the maximum, and then we keep going. Oh, okay, so this one shall be slower. All right, so this one will be divide and conquer O n log n. All right, so divide and DC, okay, called DC, and we'll have low and high, all right, and high, and return an int, okay. So low and high, we say if low is equal to high, then we return nums low, all right. Otherwise, mid equals low plus high divided by 2. And then we say left max equals DC, low to mid minus 1. We split in the middle, right? Actually, let's just say mid. And we're going to take the mid on the left side. Okay? And the right max will be, you see, mid plus 1 to high. Once we're done, we need to find the spanning. So spanning SP max left equals math.inf, alright? Like this, and then we say for I in range from mid minus 1 all the way to low minus 1, minus 1, and we say current left, that will be 0. We say current left plus equal to nums I, and SP max equals to max spanning max current left. Right, so we do the current left, do the current right, so right, right, and for the right, why do you do mid minus 1? This is mid. This will be plus 1, right? And this will be high plus 1. Alright, and same thing, right plus equal to this, right equals right and right. Alright, so this one will find the maximum spanning by adding these two together. So when we return the maximum of left max, right max, and spanning max left plus spanning max right. Okay, now simply return DC. Low will be 0, high will be land nums minus 1. Okay, so number 2. Yep. Okay, try it. Oh, yep, that's about right. Because it's over log n, so it's slower. That's 2,000 milliseconds, as required by the problem description. Okay, so that's that. All right, let's roll another one, as a tradition. I think I have one more, no, maybe like 3 more on this page that I can do. Rectangle area, that's the 1, 2, 3, yeah. Yeah, that's 3 more. Yeah, we're not gonna do this one. Transpose. We do rectangle area then. Rectangle area. Right, compute the area of a rectangular space. Is that what it is? Oh, people hated it. I wonder why. Given the coordinates of 2 rectilinear rectangles in a 2D plane, return the total area covered by. Interesting question, actually. The first is defined by bottom left and top right. Second is also bottom left and top right. Oh my goodness. Okay. So basically, we're trying to find overlap, right? What we can do is we can simplify this problem into how about we simplify it into what if they do not overlap? Yeah, we can like don't think about 2D. Let's just say like 1D, right? Yeah, let's just say 1D. It's a range, right? This is -3 to 3 and from 0 to 9, right? So we want to find merge interval, right? A merge interval, we just find the minimum of this, maximum of this, and minimum of the left, right? And a maximum of the right. And then, actually no, we're going to find a maximum of the left and a minimum of the right. Well, that gives us the intersection. Isn't that what we want, right? That is exactly what we want. We can compute this plus this and minus the intersection. So we find the intersection on, say, x on the x-axis, right? The interval on x-axis, and then we find the intersection on y-axis, and then we compute that. And if any of these is a 0, then we return 0. So I think that shall be it. So this one is 223. Do 223. I did 230 earlier today. I didn't do 223. I think I missed it. Oh, that's funny. Yeah, I think I missed it. I don't know. Sometimes you miss it. I do not like the signature. That just so when I say area 1 equal to ax2 minus ax1. All right, ax2 minus ax1 times ay2 minus ay1. All right, area 2 equals AX, no, not AX, B. Oh, one is called A, one is called B. Okay. A and B, all right? So it'll be BX1. Oh, okay, okay, not too bad. Let me just replace all the A, all right, with B. All right, so now I find a overlap. Overlap on the X, right? So overlap X left, overlap X right equals, well, and the maximum, all right, and the maximum, maximum what? Are we going maximum or minimum? Maximum. Maximum AX1 and BX1, right? And on the right side will be minimum AX2, BX2, all right? And then exact same thing. Maybe not. Maybe we can just go if OXL, if OXL is larger than OXR. Actually, larger equal to, because equal to will be 0 as well. That will just return 0. No, we return A plus B. So why do we have A plus B? We just say, we call it AB. All right, let's call AB equals this plus this. All right, and this will be OY. Oh, it's not left. It's the top and bottom. OY top, overlap OY bottom, and this is just going to be all the X will be substituted Y, right? And we say if this or OY. Oh, hold on. The top and bottom is smaller, so bottom is go first. Bottom is the maximum, yeah, and top is this. So I say if OY bottom is larger or equal to OY top, then we simply return AB, right? I also want to return AB minus blah times blah. So the first blah is OXR minus OX left. This one's OY top minus OYB. Okay. Alright, so what's our test? Oh my god. Oh, I hate it. I hate it with my guts. Look at this. I have to type in minus 3, 0, 3, 4, 0, minus 1, 9, and 2. Answer is 45. Minus 2, minus 2, 2, 2, minus 2, minus 2, 2, 2. Back to 16. Okay. X1, a Y1, X2, a Y2, BX1. Alright, BY1, BX2, BY2. Compute area. Oh my goodness. Copy and paste the entire thing again. This is bonkers. Okay. Looks good. That looks good. Okay, let's come in here and go. Pending, judging, passing. So it's 1, a 2 rounds of interval merging. Merge interval. Okay, so what's the runtime? Well, The runtime is 01 because only have one interval, two intervals to merge. 7%. I'm pretty sure this is I think we hit it on the nail. If you want to laugh, look at my solution. Okay, I might want to laugh. Oh my goodness. Oh wow. Oh, 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 oh. All right. This is what should I say? I don't know. What should I say? That's fun. Huh? That's fun. Hmm. Minus. Look at that. Look at this baby here. So we'll avoid this. Quite smart. Which means the right. So when this happened, like why would this happen? Well, this happens because OX left is larger than OX right, right? So OX right is a smaller value. It's a smaller value. So we need to take the maximum. So we take the maximum of this and OX left. All right. This means if OX left is larger than OXR, this will return OXL. Otherwise, it will return this. So we do the same thing here. Let's see, max this and OY bottom. And we can avoid doing this. We can still do it. We can still do it. It will be a little bit ugly, but that's fine. Yeah. Oh shoot, that is going to be very ugly. So we can do this, right? And we'll do this. OYT top. All right. And then this will be OY bottom. And we put this. Yeah. And delete this one. There we go. So 4 lines. Oh, technically you can do it even 3 lines. Right? And just right? So now it's 3 lines. So update a little trick from I'm gonna upload this from here to avoid explicit if clause and make it into 3 lines. All right. This won't be any faster. It's just for fun. I mean, what's life without fun, right? All right. Let's go. Go. No, slightly faster. It doesn't make any difference. All right. Okay, that's it. Well, let's do another one. Thanksgiving. We're in good spirits, so let's do 3. telling you, man, if I do 3, that will be a record. All right, so I did 2 in the morning, and if I do 3 in the afternoon, that will be 5 in a day. That will be a record. Okay, so product of array except self. Not sure what this is. The title is quite confusing. Product of array except self. Given an integer array, return an array answer such that answer I is equal to the product of all the elements nums except nums I. The product of any prefix or suffix of nums is guaranteed. It must run out in the when time without using the division operator. Oh! Without using the division operator. So it's these, right? And 12 to 1 times 3 times 4, 8, 1 times 2 times 4, 6, 1 times 2 times 3. Okay. So the requirement is to run in O(n) time and not using the division operator. How can I do it without using division operator? Oh yeah, you just multiply everything and then we just divide. We divide. So if we use division, right, we can just say total equals, is it reduce in functools? Oh wait, it's imported. So when we reduce, I think I can go import operator, right? I can go operator, wait, maybe it's operators. Mult and nums, and we return this for n in nums, total divided by n. Not sure. Just pull this out of my head. Let's see if no module names operators. So maybe it's operator. Hey, nope. Python operators mult. It's not called operator. Or maybe it's already imported. Yeah, I have to import. Operator, yeah, operator. Has no attribute mult. Probably is not mult. What is it? Mole. It's not molt. It's mole. Oh, division by 0. Huh. Want to have division by 0 problem. Hey, what if it's a 0? Well, Well, it is interesting. Plus, we're not supposed to use division numbers, so yeah, I'm not gonna use this. I mean, we can always, like, let's say, count how many zeros, right? If it's more than 1 0, then everybody is 0. If there's only 1 0, then we can remove that 0 and then do the remainder. That's how I will solve zero problem. But I don't feel like that is the way that they're looking for. Then how do we do this without using the division operation? Without using the division. And everybody multiply together except for me. I do not multiply. Okay. Where's 24? 24 is these multiplied together except from the first one, all right? So if I can get, let's say, the multiplication of these two, how do I get a multiplication of these two? Multiplication of these two. And without using a division. Okay. But without using the division seems tough. How? How can we do this without using a division operator? I mean, division. If I have, right, if I have a prefix, not a prefix, like a, what should I call that? Like if so at the beginning, I know the um, product of all these, right? And when I move on to the next one, if I know the product of this, which means we can build up a suffix product and a prefix product, right? So at whatever position, all I need to do is the suffix product multiplied by the prefix product, all right? So that is ON and also without division. It's all multiplication. That should work. It's not ON, it's not O1 extra space, but that's a start, right? We start there. That's where we start. It doesn't have to start with that more difficult. I think 01 will be more difficult. But probably similar idea. It's just usually these 01 space is, you know, space optimized. I have some certain tricks. So we're gonna have a pref, right, and a suffix. Pref and a suff. Both are going to be this and this, right? Actually, maybe if we put 1 on 1 there. That's fine, but let's do this. Nums 0, that's prefix. Nums -1, that's suffix. And then say for I in range 1 to len nums. Alright? And pref dot append nums I multiplied by pref -1. Alright, as prefix j in range, this one going to be len nums -2 all the way to 0, right? And then the suffix dot append. Oh, holy guacamole! Remember, it's different. We have the calculator. It's fine. It's fine. It's easier this way. So nums j, right, times suffix. So once we're done, we're gonna return, right, something for I, for k, in range, len nums. Alright, so k. So it's gonna be the prefix something times the suffix something. And prefix something will be k, right? Because the actual one, k will be +1. K + 1 - 1 is k. Suffix. So suffix is a little bit complicated. So it's going to be let's put n equals len nums. So all my len nums and swap with and so I have this, this, and this. Oh shoot. Again, I think I pressed the wrong button. There's this, n, right? So this will be n minus k, right? K actually, hold on. If I have position, let's say position here, so index is 1, right? Then we need this, and that's a 1. So, the next 1, right? Which means you have the second one, so k + 1, right? Is the second one, and a total number, the n, minus k + 1, that's 2. That means this is going to be 2. So I'm pretty sure it's -1, right? That's the total number, and because we have one more, we start one more. So yeah, I feel like this should be it. Okay, let's put this test. So we have this. The answer shall be this. I mean, the benefit is we don't have to handle the 0 case anymore. I mean, technically, we can also like check if there are more than 2 zeros. But we don't have to. Nums, product, nums. That is not correct. What the hell? Right, let's print pref and suff. Pref 1, 2, 6, 24. Suffix 4, 12, 24, 24. Okay. So when the zero's in, prefix. Oh shoot! I don't know what I was thinking. I don't have an extra value. No, I don't. Now I realize extra value is actually quite useful. Make the logic easier. Alright. And we don't have, let's do this. Right. And then we can do just n minus 1. Right. And this has, there we go, now it's passing. Alright. Let's do this first. And then think of a better solution. Yeah, time-wise, it's correct, right? So create a prefix and a suffix product. Prefix and suffix product lists, and this allows us to solve the problem in O1 and without using O1, geez, ON, without using the division operator. So it's ON times 241. That's a 59% ranking. So it's like regular normal play. But this is not O1 on a space complexity. So in that department, we need to keep digging. I mean, a difficulty of keeping an O1, let me think. We can, right? If for every single position, on the left side, it's growing, right? On the left side, it's always growing, so it's fine. But on the right side, if we don't do division, that will be very difficult. Yeah, how do you do it without division on the right side? I mean, what I'm saying is, we have pre and suffix. These can all be 1. Well, suffix actually is not 1. Suffix is going to be everybody multiply together, right? So it's going to be reduce. Func tools import reduce and import operator. All right, so suffix is going to be reduce operated on mul nums. All right, len is this. and the rest is this. We just go for any nums, rest.append, right? Append what? Well, we're always gonna append pref multiplied by suffix. Oh, now we have the issue of, damn. We have the issue of division by 0. So no. Hold on, let me think. Are you thinking what I was thinking? 2 rounds. But as we're building up, we also go the opposite side? Is that what you're saying? But they're not synchronized. No, let me just return to the previous one. Now, this one is not working. Yeah, if you want to divide, you run the risk of division by 0. How do we do O1? I mean, on the left side we can do because it's just keep multiplying, keep multiplying. On the right side, we're shrinking. That's the problem. If we're shrinking, then we have to do division, and if we do division, there is a risk of divide. Not there's a risk. It gotta be divided by 0. So interesting. How do we deal with an O1 space? Yep, I know. We'll do it 2 times. Right? We'll do it 2 times, and because it says the output array does not count, right? So we can create the output array. So this is O1 extra space except, right, not counting the return value. So we have result equals to 1 multiplied by n, right? So that's that. And we're just gonna run the same operation twice. So we're gonna go front to back and then record in this. So we're gonna say for any nums, right? For in in enumerate nums. The first one, right? The first one is actually shouldn't put in, right? And then the second one, and I would multiply. Hold on. We're almost there. So we are going to multiply, right? Multiply myself, and after we multiply myself, that's the multiplication to this position, right? But I'm at my disposition. I cannot do it. I have to go to the next one, right? Go to the next one. We put previous one into it, and then do me, right? So we're gonna do the previous one into it, but we can't, right? Because I is 0. There's no previous one. Therefore, I have to go for I in range 1 to n, right? So we can say, actually, let's do pref, right? Prefix equals nums 0, right? So when this happens, we say res I minus 1, right? Wait, is it I minus 1? So I'm currently at this position, right? I'm at my position. I should do I. Yeah, I should do I. So res I times equal to pref, right? Res I times equal to pref, and then pref times equal to nums I. So that's one round. Then we're gonna do another round, right? So another round, I'm gonna call suffix, and suffix is gonna go to the last one, and it's gonna be n minus 1, right? And minus 1, minus 1. We start from the last position, and the same thing. Oh, minus 2, right? The last position times equal to suffix and suffix equal to this, and I return this. All right, let's try this one. Yep. So this is what people say. All right, let's put these in one line, make it look nicer. Okay. All right, let's go. Oh, shoot. Variable n. Screw this. Oh, my bad. Should have run it first. That is a necessary runtime error. Yeah, it's the same time, but the memory usage is lower. So the O1 is the same. It is the same logic as solution 1, right? But we perform prefix and suffix product along the way, right? Along the way, and also do it along the way, and we compute the suffix product, right, from back to front such that it resembles a prefix product procedure. All right, so this is O1 extra space. We run 234 milliseconds. Got to 81% ranking. All right, now it's time to check the discussion. ON without extra space. Let's see. Yep, I think that's exactly the case. We have this for this. I equals. Oh, we don't even have to have. Well, that's fine. It's fine. And then the other way around, we have this. You can, like, I put 1 into it, and the first value. That's fine. That doesn't matter too much. Yep, that is one. Okay, that'll be it. We're done. 3 questions for the second session. 5 questions in total in the day. Wow. I will see you. I will not see you guys tomorrow, because tomorrow I'll be traveling. I will see you guys on Friday. Adios.